Hi, I'm Bob. Welcome back to 5 Minute Econometrics. Last time, we explored the differences between cross-sectional and time series data. Cross-sectional data capture the variation of different individuals in a single point in time, while time series data follow the same individual over multiple time periods. The key distinction is whether observations vary across space or across time. Cross-sectional data describe different individuals distributed across space, while time series data describe the same individual observed at different points in time. Today, we will introduce two important types of time series models: the static model and the finite distributed lag model. The static model is a special case of the finite distributed lag model. For time series data, we use the subscript t to indicate the time period. A finite distributed lag model allows the explanatory variables x to affect the outcome variable y with a lag. Here is the distributed lag model with 3 lags. The coefficient sigma 0 is called the impact propensity or shock run propensity. It is the immediate change in y due to a 1 unit increase in x at time t. Similarly, sigma 1 is the change in y due to a 1 unit increase in x at the previous time period. This finite distributed lag model assumes that y is affected by x contemporaneously and with 3 lags. The sum of the coefficients of them, that is, the sum of sigma 0, sigma 1, sigma 2, and sigma 3, is called the long-run propensity, LRP, or long-run multiplier. The long-run propensity, LRP, is the long-run change in y due to a 1 unit increase in x, representing the total cumulative effect of a permanent 1 unit increase in the explanatory variable on the outcome variable over time. For example, this model uses different variables to explain the general fertility rate, the number of children born to every 1,000 women of childbearing age. These variables include the average real dollar value of the personal tax exemption, whether it occurred during World War II, and whether it occurred after the birth control pill became available. We estimate a distributed lag model with 2 lags of the personal tax exemption. Here is the estimated result. None of the coefficients for the 3 tax exemption variables is individually significant at any conventional level. The reason is that the 3 tax exemption variables are highly correlated, and this severe multicollinearity leads to an imprecise individual estimate for each tax exemption variable. However, they could be jointly significant at small levels. The sum of the 3 estimated coefficients for the tax exemption variables is the long-run propensity of personal tax exemption for the fertility rate, which equals 0.101. If we want to find the standard error of the long-run propensity and do statistical inference, we have two methods. First, we can use Stata's lincom command to obtain the long-run propensity and its standard error, along with the t-statistic, the p-value, and 95% confidence interval. The second method is to rearrange the variables so that a coefficient equals the long-run propensity. To do that, we denote the long-run propensity theta 0, which is the sum of sigma 0, sigma 1, and sigma 2. Then, we replace sigma 0 with its expression and have a new regression equation. We obtain the OLS estimate for the long-run propensity theta 0 hat and its standard error by estimating the new equation. Using either method, we find the long-run propensity of the tax exemption on the fertility rate to be 0.101, with a standard error of 0.030. The t-statistic is 3.37, and the p-value is 0.001. The long-run propensity is statistically significant at any level above 0.1%, although each of the individual tax exemptions is insignificant. A static model relates the outcome variable y to the explanatory variable x contemporaneously. It is a special case of the finite distributed lag model in which the lag coefficients are 0. There's only a short-run propensity in the static model. There's no long-run propensity in the static model. Today, we have discussed two fundamental time series models, the static model and the finite distributed lag model. The former is a special case of the latter. The static model describes a contemporaneous relationship between x and y, while the finite distributed lag model captures the cumulative effect of x on y over time. The long-run propensity measures a total accumulated change in y due to a permanent 1 unit increase in x. Thank you so much for watching this video. See you soon. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.